When I say make room, what I'm going to do here, guys, is I'm going to take this 11 and I'm going to put it on the other side so it becomes negative 11. And when I say make room, what you're doing is you're trying to add something here, okay? And what we want in completing this square the goal is we want a perfect square trinomial. You wish you had something so that what the next line is going to be, it's going to be something squared, a binomial squared. And actually, I can tell you, it's going to be x, right? Because that's x squared. Actually, I can tell you one more thing. I know the sign that's going to be here. Do you guys know the sign that's going to be here? It's going to be minus because I need to get 12x, okay? But what gets lost sometimes is what goes in the blank, and so I have a rule about that. And so the question, what do I add? And the answer is half of the coefficient of x squared. Okay? And those of you that know this, I apologize, but I just think it's worth me getting everybody on the same page and recalling how this works. This is going to be half of what? That negative 12 squared. Some of you just said 12, and that's fine. It doesn't matter if you're going to square. And you guys know what of is in the math classroom? That means times, right? So it's half times. And how do I write negative 12 as a fraction? Sure. So a half of 12, of course, is negative 6 here squared. And so what is it you're going to add to both sides? You're going to add 36. Are you with me? If you do that, and you add 36 where you made room, and you add 36 over here, you've got it. You now have a perfect square trinomial. Okay? So let's see what we get. We get x minus what? 6, because 6 squared would be 36, right? Is equal to, and then it just so happens that negative 11 plus 36 is really nice. This doesn't usually happen, but you get, and why is that nice? Yeah. It's exactly like number 1, what you said you did for number 1. You take the square root of both sides. But of course the rule is when I take the square root of both sides, I have to remember to do what? Plus or minus. So I get, when you take the square root of x minus 6 squared, you just get x minus 6. It's going to equal plus or minus, well, 5, right? And so you get two solutions. You get x minus 6 equals 5, or x minus 6 equals negative 5. Right? And so you get x equals 11, or x equals, what would it be? 1. Okay, now why show you this? Well, because it's going to be very important today. Today, I'm going to say something like this. I'm going to say graph. I'm sorry, what? Something doesn't make sense? Yeah, if you put an 11 and square it, and then add another 11, and now you have 12 times 11 minus 12 times 11. It works. Troy, was that you? Today we're going to say something like this. Graph the equation y equals x squared minus 12x plus 11. I'm going to say graph it. Right? How do you graph that? Well, so far all I told you guys is, hey, if that number in front of the x squared is positive, guess what? It's an upward parabola, but this does not tell you at all really what the graph looks like other than that. And so now it's like, well, what do you do? Well, we could do inputs and outputs like we did at the beginning of the year. So for example, what's the y-intercept going to be? Well, I can plug in x as 0, right? So somewhere up here is the point 0, 11, if that's the y-axis, let's say. Okay? But it doesn't tell me what the x-intercepts are. Now to get the x-intercepts, okay, you want to solve what? So for the x-intercepts, yeah, change the y into what? 0. So we get 0 is x squared minus 12x plus 11. And now, didn't I just do all that? I just solved that, right? So what I was really finding is I was finding the x-intercepts of this function. Does that make sense? So where are they, x-intercepts? I guess they would be, well, here. If this is your x-axis, here's 1. It would be 1, 0. And what would this other one be? 11, 0. So it's like you're starting to get you're starting to get the shape of the graph now, in a sense, right? Of course, we solved them by completing the square. We showed you could solve it by factoring. What's the other way to solve this one? Okay, remind me what the quadratic formula says. The quadratic formula, yeah, so let me really be precise about this because I'm not sure how much you guys know. And so I want to be very clear about what the quadratic formula says. And it says, if I want to solve this equation, ax squared plus bx plus c equal to what?
0.
Has to be equal to 0 or it doesn't work. But if I want to solve that equation, I can use x equals negative b, or the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. And I hope you guys practiced this on your review packet, right? I'm sure you did. Okay? So I can use that. Now, here's the thing. Why do you get two solutions from the quadratic formula? Yeah, there's plus or minus, right? So if you think about it, I mean, another way to write this, negative b over 2a plus or minus, and this is the square root of b squared minus 4ac all over 2a. The reason I say that this is exactly the same thing is because it's how you add fractions. Can you add these two fractions? Yeah, they have a common denominator. And when you add fractions with the common denominator, the denominator stays the same. And so what this says is, look, to get the two zeros, or to get the two solutions, what you do is you kind of go to the middle. This line here is x equals negative b over 2a. and then you either add something to it to move this way, or you subtract something to it to move that way. This line has a name, by the way. It's called, yeah, either the line or the axis of symmetry. Okay? The axis of symmetry. And so, actually, let's check what the axis of symmetry would be for this parabola. So if I did negative b over 2a in my example here, well, see how, what's b in this example?
Negative 12.
Yeah, so you get negative 12 over 2 times what? 1. And so that's 12 over 2, which is 6. So, yeah, the axis of symmetry for our problem is x is 6. And notice, if you move 5 in one direction, you go out to 11. If you move 5 in the other direction, you go out to 1. So that's really nice that all this algebra that you learned, you can see up on the screen. Okay? And one of the things that's great about the axis of symmetry, okay, and this is important, is that the maximum or minimum value, that has a name also called the vertex of a parabola, is on the axis of symmetry. And so we're going to want to know what this is, that point right there. Okay? But I'm at 1 o'clock, so I think I better take this at this point. Okay? I think we got what I wanted out of completing the square. We may come back to it one more time today. On your way out, if you guys leave me those, that's a big page of work we did on this one particular problem. And I first did some completing the square, and then I said, well, imagine this was a parabola you had to graph, and I said, find the x-intercepts. And then I talked about quadratic formula. I talked about a lot of stuff here. Right? The one thing I didn't talk about on this example that I want to get to is the idea, again, of the vertex of the parabola. And the vertex is the point that gives you the what? Maximum or minimum value. Will this vertex give me a maximum value or a minimum value? Okay, so that's what I'd like to know is, what is the minimum value of this parabola? I mean, I know how to make the parabola equal 0. I can plug in a 1 or an 11, right? Like if I plug in 1, 1 minus 12 plus 11, that gives me 0. But if I want the minimum value, what is it that I have to plug in for x? 6. Why 6? How did we get that? Yeah, what formula did we use that's very important for the axis of symmetry? Negative b over 2a. That's kind of the key. And again, it's because it's like the middle of the solutions, right? Negative b over 2a can be used to help you find the minimum value. But if I ask you what is the minimum value, okay, so let's do it now. How do we get the minimum value? Well, we're going to find y of 6. Do you guys understand what I mean when I write that? I'm saying use 6 as the input, right? So what would I write? I would write 6 squared minus 12 times 6 plus 11, right? 6 squared is what?
36.
Okay, minus 72 plus 11. Now 36 minus 72 is negative 36 plus 11. Do you know what I get? Okay, the minimum value is negative 25. So in other words, we just computed that this point is 6, negative 25. Okay? Now, I'm telling you, that's a lot of work we did. There is an easier way It has to do with completing the square. Okay? And let me show you. I mean, you might even already see it. Here, let's do a redo. Ready? Okay. So I want to find the vertex of y equals, what was it? Oh boy. X squared minus, help me out, 12x plus 11. Thank you. Okay. So I want to find the vertex. And actually more. I even want to graph it, right? But finding the vertex is definitely part of it. Okay? So one thing we can do is we can complete the square. How do we do it? Well, I'm going to make room. Remember that step? Well, watch how I make room in this situation. Y equals x squared minus 12x. And let me just put the plus 11 over here. I made room. Okay. Do you remember what it was we added to both sides of my equation?
36.
Okay. So I add 36 here, and I add 36 here, right? And so on this side, I guess I have y plus 36 is equal to, and this turns out to be x minus 6 squared plus 11, right? And then what do you do to both sides? Now let's get the y by itself. What should I do? Subtract 36. And I get x minus 6 squared. What would it be? Minus 25. Minus 25. I'm telling you, that's enough to graph. Putting it in this form. Why? Because you guys studied transformations. Right? I mean, yeah, it's what Troy just said. We know the basic equation y equals x squared. That's kind of like what you might call the parent function. That's the most basic quadratic function there is. And what's the vertex of y equals x squared?
0, 0.
Yeah, you'll never get a negative number. The lowest you could possibly get is at 0, you get 0, right? Well, think about it. Can you transform this into that? Sure. Is there a vertical shift? What's the vertical shift? Down 25. Is there a horizontal shift? To the right 6. You see, that's really nice. Okay? So if I go to the right here 6 and then down 25, I'm at the point once again, 625, and that's my picture. It goes through 1 and 11 and keeps going. But okay? So that's really nice. And your book is going to, there are advantages and disadvantages to these two forms you're going to see. Tonight's homework. Graph the quadratic function. Find the x and y intercepts of each graph, if any exist. I already showed you those, right? We had a y-intercept, and then we had 2 x-intercepts. But it says if any exist. I'll show you one where they don't in just a minute. Actually, I think Matei was talking about an example from where we got imaginary roots. We'll look at that in a second. If it is given in general form, convert it into standard form. If it is in standard form, convert it into general form. Okay? Now, it's funny because I have trouble knowing which form is which. Okay? I believe this is what the book would call standard form, and this is what the book would call general form. But more importantly, I want you to know that this is in the form ax squared. Do you know what I'm going to write next?
Say what?
Plus bx plus,
C.
yeah, That's what the book calls the standard form. It's the one that the quadratic formula is associated with. But this one, we could write as y equals a times x minus h squared plus k. X minus h squared plus k. H, remember, stood for a horizontal shift, and k was a vertical shift. Okay? So that's kind of nice to know about. All right. So I want to go through maybe some of the even problems with you for a minute. Look at number 2. We have f of x equals negative x plus 2 squared. And so I have a few things to do here. I need to graph. I need to put it into the other form. I need to find x-intercepts and y-intercepts. What else does it say? Domain and range. I mean, all the stuff we've been doing in Chapter 1, we're going to try with these. And it says intervals, where it is increasing, decreasing. What else does it say? Vertex. And the axis of symmetry. Oh, one other thing about the vertex. The question is that a max or a min? Here, I have a little list here for you guys here. So the question is this vertex a max or a min? So these are all the things they want me to do for one particular problem. I think I assigned 1 to 19 out. I think there's 10 problems total to do. And actually, some of those are not this. About half of them are this kind of problem. The other half are a few of those profit function applications, right? You're going to find the maximum profit or the minimum, sometimes. But anyways, I think the first thing to notice, okay, if we're going to talk about the graph here, right, is again, I know what y equals x squared looks like, right? Y equals x squared, I know, which is kind of my parent function, looks like this, right? So tell me about the transformations we're going to do. You're going to do the left two. That's right. One of the reasons that I wrote x minus h in my formula is because you kind of move backwards, don't you, when you have the input, right? So if it says plus 2, that means move to the left. Okay, so I'll move to the left 2. And then, what else am I doing besides that? The graph gets reflected, and so this is going to open downwards, right? So there's a picture already in red. I've got a graph. Okay. Well, interesting. Okay. I guess I'm going to turn you guys loose on these questions for about 5 minutes, and then we'll talk about it. Okay. If you finish this one and want to try another one, I will put another equation up here on the screen also. Okay. But we'll turn you loose. Please work with somebody. Don't work alone. All right. At least check your answers with somebody as you go, okay? And let's see how this goes. Okay. So you guys sketched a graph. Did you put it in the other form? When you put it in the other form, should I distribute the negative first or square first? You have to square first, right? You do exponents before multiplying. So the other form would be f of x is, let's see, x squared plus 4x plus 4 if I square that, right? And so I get f of x is negative x squared minus 4x minus 4. You guys with me? Okay, so I got the other form. I got the graph. X-intercepts, you set the y equal to 0. So that's like this, negative 2 comma 0. Y-intercept, oh, that's easy, right? What do? Set, okay, so what I really need here is f of 0. And I think it's easiest if it's in this form. But you could do either form. You're going to get negative 4. Okay, so 0, negative 4 is the y-intercept. So we got those. You guys, the domain for anything in this section, the domain, that's asking you what x's are you allowed to put into the function. Well, anything. Negative infinity to positive infinity, right? But what's different, I guess, is the range. What would be the range for this one?
Negative infinity to 0.
Yeah, the highest it can get is 0. Can it actually equal 0?
Yes.
So I should put a bracket. I would say when we talk about intervals where it's increasing or decreasing, it starts off increasing from negative infinity up to what?
Negative 2.
Yeah, remember when you talk about these intervals, we're talking about x values, right? Inputs. And then it's going to be decreasing from that negative 2 all the way to infinity. Okay. And you know the vertex is negative 2, 0, and the axis of symmetry, I guess, would be x is negative 2. Okay. So now I have to try again with the other, do all of this stuff with that other equation, number 6, negative 3x squared plus 4x minus 7. Okay. So here I go. This is more challenging. I mean, here, let me use graph paper. F of x is negative 3x squared plus 4x minus 7. Wow. Some of this stuff is a lot harder for this problem. I mean, first of all, I'm not ready to immediately sketch a graph because I kind of want it in the other form, right? How do I do that? Well, see, I claim it's easy to go from this form to the standard form. You just multiply. But do you see how the other way is harder? You have to do completing the square maybe, right? Although I'll give you a shortcut in a minute, which I think will make sense to you. Here, watch. Now maybe we'll do that next. Let's do something else first. Is there any of this stuff we can do easily? Ah, what's the domain? Okay. How about the range? I don't know. I know the range will be interesting because it either has a maximum or a minimum. Hey, do I know which it has? Which way does this parabola open for number 6? It opens downward. So that means it's going to be negative infinity to something. I don't know what. I'll just put a bracket. I don't know yet.
Could you do y-intercept?
We can. How would we do the y-intercept?
0 into x's.
Okay, let me get that. I know that the y-intercept is going to be 0 comma something. What is it? Negative 7, thank you. So we've got that. Let's see. We did domain and range. Intervals, I better wait till I see a graph. Vertex, axis of symmetry. See, do you agree that this would all be a lot easier if we had it in the other form? Okay? So I'm going to do a little work on that right now. Show you some work. And again, it's going to come down to this completing the square. You're not going to like these calculations, but I'm going to do them for you. With you. Ready? Trying to put this in the other form. Let's write it as f of x equals, and I'm going to take the negative 3 and factor it out. And you might say, Paul, what the heck are you doing? Well, let me show you. Remember the other form, it's just right above this. Here, let me show you. What is it that has to come out front of the x minus h squared? See that a? So you see what my a is going to be? It's going to be what? Negative 3. But here's the thing. We need the stuff in parentheses to give me back what I started with. Let's see if this makes sense to you guys or not. Do you see how that's going to be just x squared? Okay. Now the next part is going to be minus 4/3 x. Do you see that? Well, you could check your work. Like, if I distributed the negative 3, what would I get back? Positive 4x. You with me?
Yeah.
And I just left the minus 7 out there for now. Okay, next step. F of x is negative 3 times stuff minus 7. This step is called make room. What is it that goes here? Well, it's x squared minus 4/3 x, and then I leave a blank. All right, let's go through. What goes in the blank? I went through this with you. Half of what? Of negative 4/3 squared. That's what I have to add. So that means half times what? Negative 4/3. And then square it. So can you cancel? Yeah, what's half of negative 4/3? Negative 2/3 squared. How many are with me so far? Really? So what am I going to add?
Negative.
Well, first of all, it's going to be negative or positive?
Positive.
Positive
4/9. That's right. In the blank, I'm about to put positive 4/9. Remember when I told you you wouldn't like the calculation? I told you. But this is the weirdest part of this whole problem. You can't just add 4/9 to one side unless you also add, obviously, negative 4/3 to the other side. What? Okay, slow down, Paul. What did you actually do? See, I didn't really add 4/9. If you think about it, what did I really add? I really added 4/9 times negative 3. See that? Because the negative 3 is outside there. What is 4/9 times negative 3? Yep. That's negative 3 times 4/9, if you're wondering where the heck that came from. Okay? Now, let's see how this works. Negative 4/3 plus f of x is equal to negative 3. Because we did completing the square, we're going to get stuff here.
Oh, yeah.
Squared, right? That's why it's called completing the square. You get something squared. Here, I'll help you. Ha! That's an x, right? Has to be. That's how you're going to get x squared. And actually, this binomial, do you know what the sign's going to be?
Negative.
You're right, because it's got to give you the minus 4/3. Now, the hardest part, do you know what goes here?
2/3.
That is 2/3. Very good. Very good. And so, well, this is kind of ugly, but what we get is we get f of x equals negative 3 times x minus 2/3 squared. And then Well, it's not going to be minus 7 because what do I have to do?
Add 4/3.
Yeah, I have to add 4/3 to 7, and I'm getting there. But hold on. I'm already at a good point here. All that is the long, difficult approach. But it worked. I mean, what did it help me figure out, for instance? Well, for instance, do you guys know what the axis of symmetry is? Well, you guys, how about the basic parabola? Y equals x squared. What's the axis of symmetry for your basic parabola?
X equals 0.
X equals 0. This is like a basic parabola, but we did some transformations to it. Do you know, Seth?
No, but shouldn't that 4/3 be 4/9? Because you added 4/9 to that side. Shouldn't you do both?
No, I actually added 4/9 times -3,
Oh,
which is
okay.
the -4/3 to both
Okay,
sides.
what is
Okay? I see why you thought that, though. But see, I don't want you guys to ever have to do this again. I mean, that's ugly. So I want to do it the easy way. You guys, the axis of symmetry. We have a formula for it, right? It's x equals what? Negative b over 2a. Didn't we already have a and b at the very beginning?
Yeah.
We did, right? What was b?
4.
So -4 over, what was a?
-3.
2 times -3. So let's see what we get. -4 over -6 gives me what?
2/3.
Da da da! You see that? It's just 2/3. So you knew the axis of symmetry was x equals 2/3. So if I said find the vertex has to be 2/3 comma something. How do I get the something? Well, the something is going to be f of 2/3. F of 2/3. Right? So if you plug in 2/3 for your vertex, you'll have it. For your x. Let me compute what that is, guys. F of 2/3. What does that mean to do? Oh boy, we're running out of room. Well, I just have enough room barely. Means everywhere that it used to say x, what am I going to write? Okay, so this is being careful. -3 times 2/3 squared plus 4 times 2/3 minus 7. And now I got to bring that up here and do some work. -3 times 4/9 plus 4. How do you write these things as fractions? Well, you just put them over 1, right? So let's see. This is -4/3 if I cancel, plus 8/3. And then how would you write 7 if you wanted to write it as a bunch of thirds? Well, 7, it's 7 over 1, right? So how many thirds would it be? 21, right? So if you work this out, -4 plus 8 minus 21, so 8 minus 25, I'm getting minus 17 thirds. So remember I said I want to write it in the other form? I think the long, difficult approach would be to do all this completing the square stuff here. I think the easy approach would be the following. You say, okay, I'm going to do this. I know it's f of x equals -3 times something squared plus something. Because the -3 is the a. And then what am I going to write? X minus what? Where's the 2/3 come from? Well, that was the -b over 2a. And now what's the rest of it? Minus what?
17.
17 thirds, okay? And I'm telling you that this is enough to figure out what the graph looks like, basically. I mean, where is the vertex? We figured it out now. The vertex is 2/3, comma,
Negative 17 thirds.
negative 17/3. Which way does this parabola open? Downward. Here's the picture of it from your book's solutions. It's over 2/3, it's down 17/3, right? You can get the y-intercept of -7 like we talked about before. By the way, what about the x-intercepts? I don't see any, right? And you might say, well, why'd that happen?
Unless you shift it down, since you shift it down and it's going now.
Yeah. But what if you actually tried to find them? Here's the original equation. F of x is -3x² plus 4x minus 7. And so if you were going to solve this, 0 equals -3x² plus 4x minus 7, at some point you'd probably say, I need the quadratic formula because I can't factor this. And at some point, when you were doing the quadratic formula, this might come to mind. b² minus 4ac. Do you know what that is in the quadratic formula? Which part is that?
That's the inside square root.
Inside the square root. I'm going to compute it. b² would be 16, because that's 4 squared, minus 4 times -3 times -7. 16, is this going to be a plus or a minus with all these negatives here? Minus 12 times 7 is 84. The point is, it's negative. And if you have a negative under the square root, guess what? No real solutions. That's why there are no x-intercepts. You see that? So that's really kind of cool. I think everything else you could probably do on this problem. I only have about 1 more minute for questions on this. Do you have any more questions on this one? Yes. Good question. What is the range? Maybe I have to zoom in for you to see what they put. Well, actually, we knew part of the range, right? We knew it went down as low as -infinity, right? So how high does it go? What's the maximum value? -17/3 would be what it went up to. That's right. Okay. Nice work today, you guys. Excellent. I'll see you on Thursday.